Okay, so we are trying to measure the pressure of the tank that already I show you last class, right? And I already show you how to calculate if you travel from point D to point A. Now we'll travel in opposite direction. Then what will be happen? So inside the fluid, if you come downward, then it will be positive value. And if you going upward, then it will be negative. So let's start from point A. So point A mean you are right over here. Then come to the point B. That means you are going down. So obviously I'm putting plus sign. How much going down? Height H1. So H1 rho G. That means now you came in point B. Point B mean you are in point C. Now you are moving upward. So there will be minus sign. How much height you are going upward? H2. So H2 rho of manometric fluid. I putting rho M into G. Now where did we come in? Now in point D equal to pressure at point D. How much pressure? P atmospheric pressure, ATM. Now this equation and this equation is same. We figure out the PA from here. Right hand side you get P atmosphere. Rho manometric, this will be positive. It is negative, so it becomes right side, it will be positive. And this one is plus. You take right side, this will be negative. Okay, so any way you can walk down to figure out the pressure in the particular tank or between two tank. Okay, so let's see the next slide. Is what is that one? Is a simple manometer or differential manometer? Anyone? This one? This one is a differential
manometer.
manometer. Thank you. Okay, because in giving pressure difference between point A and B. Now, how we can figure out? You look to the picture, your manometric fluid in the bottom, right over here. And it's a fluid rho man, okay? And height of the difference of manometric fluid is this much. That means H. And the fluid passing through the tube, it is inclined, and vertical height from point A to C is HA, and vertical height from B to D is HB. So easily you can figure out this height from B to point D, right? HB minus H. Now, you have two options. You see point C and D in the same fluid and same vertical plane, right? So if I choose B and C is my common point, then you figure out the pressure at point C and figure out the pressure at point D. Then we say PC equal to PD. Then you can figure out the difference of pressure. So let's see, start PC, that how we can figure out the pressure PC. Okay, so PC equal to, I start from point A. How much the pressure point A? PA. I'm saying PA. Then from point A, you need to walk down point C. That means you are coming down. How much height? HA. So I can say HA rho G. This is pressure at point C. Similarly, you figure out the pressure at point D. So PD, how did you start? You start from point B. How much the pressure point B? PB. Then you come point B to E. So it will be positive. How much the height? Is B minus H into rho G. Now, what did you came in now? You just came in point E. You need to come at point D. So again, we're going down plus H rho M. Then you say G. Then next line, PC equal to PD. Then figure out the pressure difference between PA and PB. So it is right over here is showing PC equal to PD, then figure out the pressure difference. Now, there is a other option, then you can walk down from one point to other point. How to walk down? Let's start with any way you can start. Let's see, we start from point A. So how will travel from point A? From point A, you coming right over here. That means pressure at right over here and right over here is same. So ultimately you need to walk down right here. Then vertical, you coming at point B. So what is pressure over here? PA. Then that means over here, PA is coming down. That means plus. Plus, what is the height? Is A rho G. Now you are point C. Point C means you're coming at point D. Now you're moving upward, come to the point E. So you're going upward, negative H rho M G. Now your point over here, you need to come down at point B. Again, you're moving upward, minus. What is the height? This height, HB minus H. So you can say HB minus H rho G. So now you are at point B, right? So this equal to pressure of point B. Then you just figure out PA minus PB or PB minus PA. Instead, in this case, fluid is moving along this direction, PA will be higher, okay? Right over here, you can do other way. You can walk down from point B and come down over here and check it, that the equation is same or not, okay? Any question from this problem? Anyone? No question, right? So we can start now. Why we use manometry by a very small diameter tube to figure out to measure the pressure? Okay, you can prove it mathematically that if you have a manometer, the difference of height of the manometric fluid between 2 points will be equal to the pressure difference. Right? For example, this case, my difference of height of manometric fluid between point C and D is this much. Since this is a very small tube, right? Diameter is small. Still, this column of height of fluid will represent the pressure difference between 2 points A and B. And this pressure might be extremely high, but by using a small tube and column of liquid, you are getting the pressure difference. So how we can prove it by mathematically. Okay, so let's see in the next slide. You see a two tank right over here, pressure P1, right over here, pressure P2. And we are thinking pressure at P1 is higher than P2. Pressure P1 higher than P2. So what will be happen? He will push down the fluid. If pressure is same both side, then both fluid will be this level. This is the reference line. This level will be right over here, and this one will be right over here. But due to increasing of pressure, P1 getting higher than P2, then you see this much fluid, some fluid move to the smaller one. How much fluid move? This much, right? This much fluid move from left tank to right tank. So we can figure out this volume of the liquid. Diameter of this small tank is D. So area pi d square by 4. And what is the height of the liquid? Z2. So this is the volume, and this much volume transfer from left side to right side. Now, how we can figure out the height Z1? Because same amount of fluid is volume is same, right? So how much the left side volume? I can say Z1 into pi by 4 divided by big D square. This much volume from the left side went to the right side, right? Or I can say, let me clear it out. I can say Z1 dot area, just keeping it area, equal to right side volume. What is my right side volume of water? Z2 into pi by 4 small d1 square, right? So similarly, Z1 will be equal to this value, right? Z2 pi by 4 d1 square divided by area of tank 1. What is the area? Pi by 4 d1 whole square, right? So now you see this pi will be out, pi by 4. So ultimately you are getting Z1 equal to D divided by small d whole square into Z2, right? That is showing right over here. So I can erase it. That means Z1 equal to this value. Now you see diameter of this one is very small. So ratio of D by do will be very small, right? Then you whole square it, again it will be small. So what we can do, this ratio we can neglect. We can say Z1 it will be almost equal to Z2 in that case, right? But right now we are not applying that rule. We are saying Z1 will be this much, D by D whole square into Z2. Now we'll apply the pressure. We'll figure out the value P2, how we can figure out the pressure. Okay, so you see what is our common line. If I make a line over here, this line will be common because both sides pressure is same. Now, I'll move from here to right over here in P2. How much pressure over here? P2. And over here, P1, right? So I'll apply manometric principle. If I apply that rule, then pressure right over here, it will be P1. P1, then what did you came in? Right over here, right? From here, you came in over here, then you move over here. So how much the height this one is Z1. So you are moving upward. So Z1 into rho G. Now, what did you came in at this point? Now you come in over here. So you came in over here, again you moving upward. So that will be Z2 rho G. This equal to P2, right? Now we'll figure out P1 minus P2. So you see right over here, this equation. So from here, if you figure out P1 minus P2, this will be rho G Z1 plus Z2, right? This will be our equation. So right over here, this is actually Z1. This Z1 will replace by this value. So P1 minus P2 equal to rho G Z2 plus Z2 into D square. That means you're taking this value, you put in the Z1. Now Z2, you take it out, take it common. So you get 1 plus D by D whole square. So you see this whole square, now I can ignore. I can say this will be value very small. That means this will be this bracket term in the third bracket. This value will be ultimately equal to 1. That means this value is 1. So value in the bracket term is 1. That means this equal to ultimately coming rho G into Z2. So what is our Z2 actually? You look carefully. Z2 is the height, difference of height between 2 points. So this must, so if you got the deflection of the manometer, that will give you the pressure difference. Okay, so it's a only one reading need to be taken to measure the pressure difference. Right over here is one more example that how we can measure the pressure difference like this tank. Right over here is 3 type of fluid, like this one gamma 3, this one gamma 1, and inside the manometer you have gamma 2. Now, how can measure the pressure? So where you can make the your vertical plane, horizontal plane, that fluid has both has the same line. We can say this point, right? So if I think this is 0.2, this is 0.3, then you figure out the P2 and P3 that we did. So P2 equal to PA to gamma 1 H1, rho G equal to gamma. So the instead of rho G, they put gamma 1. So this is the pressure at 0.2. What will be pressure at 0.3? P3 equal to start from point B. So PB, you are coming down. So plus H3 gamma 3. Then you're coming down this much, H2 gamma 2. Then you say PT equal to P3. Then you rearrange the equation, you'll get PA minus PB. Other thing, you can walk down from point A, then go to the point B. So you walk down from here, mean you are walk down from here, same thing, you coming over here, then go to the point B. So pressure right over here, how much? Equal to PA. So I'm saying PA. I'm walking down by height H1. So H1, gamma 1, this plus. Then you coming over here, right? Now you're moving upward by height H2. So minus H2, gamma 2. Then from here, you are walking this much, this point. That means gamma 3, H3, minus because you are moving upward. You coming over here, that means you are in point B. So equal to pressure at point B. Then you figure out the pressure difference. Okay. Very simple. Right over here is a incline manometer. Now, how we can figure out the pressure difference? Same thing. But right over here, just vertical height, when you figure out, you might have to use the angle. For example, you have point over here, point over here. So where will be the common point? Common point, if you take this one, this is out of the tank. You cannot take this one, right? So is better to take right over here, right through this point. Also dimension is giving. You take right over here, you see right over here, you can easily figure out the pressure, right? This 0.1, your pressure will be PA plus H1 gamma. Then figure out the pressure at this point. How can figure out? You see vertical height between point B and this is point B and point 2. How much? H3. And vertical height from point 2 to this point, how you can figure out? L2 is given, length is given, the angle is given theta. So you can use the triangular law, sine theta. So H2 is sine theta equal to H2 by L2. So from there you figure out the H2. So let's how we can figure out. We'll walk down from point A, then coming over here. Coming over here mean you're traveling vertical height right over here, right? You go over here, then you coming over here. So PA, you start at the point A, pressure is PA. You're coming over here. Then particle height H1 is going down, so plus H1 gamma 1. You coming over here mean you coming right over here. So from here, you need to walk down this point. Incline is too much distance, but we will consider only vertical height because pressure depends on vertical height. So you are moving upward, so that will be negative. So negative H2 gamma 2. So you came in right over here. Now from here, you need to come over here. That means vertical height is H3. So minus gamma 3 H3 equal to PB. Then you just make the difference, okay? So, so far, any question, anyone? Similarly, right over here, say you visit the Sri Mongol, you might have a tea in a glass, they have a different layer with different color. And so you'll see how come different layer of fluid in a teacup or in a glass. And you can see when you drink, still layer remain the same position because they have the different density. Okay. Now, how we can figure out the amount of pressure at the bottom of the jar? You have 3 layer of fluid and their height is given. So easily you can figure out by your pressure rule, manometric rule. So you figure out pressure 1, you walk down from top point. Right over here is expressed to the atmosphere. So pressure is P atmospheric pressure. So right over here, P atmospheric pressure, then you walk down. You walk down first from this point to this point. That means height H1, rho 1, right over here. Then you walk down this much, rho 2 GH2. Then you walk down this much, rho 3 GH3 equal to P1. You figure out the pressure. Okay. Similarly, right over here, you can figure out the pressure difference. So we are not going, already explained it, that one. Okay, we'll solve a problem. So anyone has any question? Anyone? No?
No, sir.
No, sir. Sadi Muhammad. Okay. So we can proceed, right? Okay, let's solve the problem. How we can solve it, this problem. Okay. It's saying a water tank is pressurized water tank by air. Pressure is measured in the tank. You like to measure the pressure by a multi-fluid manometer. That means in this manometer, you look carefully. This is the same fluid of the tank. Then right over here, different type of manometer, oil. And right over here is mercury. And right over here is 0.2 expressed to the atmospheric pressure. Okay. So it's saying this kind of tank is located on a mountain at altitude 400 meters, where atmospheric pressure is 85.6 kilopascal. Right over here is 85.6 kilopascal. Determine air pressure in the tank. Right over here, 0.1. You need to figure out the air pressure. And all the height is given. H1 is given 0.1 meter, H2 0.2 meter, also H3 0.35. And density of water, you already know, 1000 kg per meter cube. Density of this oil is given 850 kg per meter cube. And mercury density is given. Mercury is the most heaviest liquid. So how we can solve it? So at first, you write down what is given. Then draw the figure on the right side, then write down. Rho equal to, you write down, only not rho, that's the density of the oil, given density of the oil, rho oil equal to this much. Density of the mercury, rho m, or you can say rho mercury equal to this much. Then you say density of water, rho w equal to this much. Then you say manometric height, H1 equal to this much, H2 this much, H3 this much. Atmospheric pressure already given over here, 85.6 kilopascal. Then you say P1 equal to hot. That means value of P1 you need to figure out. Now, how sometime all the students said, sir, I answered all the question, but I get less mark. Why? Even your problem is right, but you are not right this way, right? You're not writing what data is given and what you need to figure out. Even you are not drawing the picture. Then what will happen? Obviously, your result is right. Still, your mark will be reduced. Then you write down all those things, given data, but in the right side, you don't draw the picture. So how will you know you understand the problem? Or which one is H3, which one is H2? So obviously, if you draw the figure, then you say data given, then you figure out what data you need to figure out. Then if your process is right, you will get the mark. Say you write this way, your result is wrong, but procedure is right. Your mark will be reduced by might be 30%. That means if you mark is 10, still you will get 7 or 7.5. Okay. So you have to be careful when you answer. Even your answer is right, that don't mean that you will get the full mark. Okay. Now, right over here, we will use the manometric. Okay. Now, you see where we can add a common point. One thing we can do, that we can start at point 1 and we walk down at point 2. How we can walk down? You see, you try to figure out the common level of fluid. Where is the common level? You see, if I just draw a small circle at point 1, and if I make a line over here from the height h1, then right over here, both points have the same pressure, right? And pressure right over here and also right over here is same, because you see same fluid, right? Water. Then from here, you came this level. My blue line is not completely right. It should be a little bit go down. If I make a line over here, so you coming this point right over here, then come over here. You coming over here, that means you are right over here, right? Then from here you can go through the bottom. Don't go the, you can just came over here. Then you came in at point 2. Okay. So let's see how we can walk down. At point 1, how much the pressure? P1. That we need to figure out, right? So P1, then come over here. Your height is H1, you are going down. So rho water G H1. So you get this one. Now you are this point, right? Then this point mean you are right over here. Then come down at this point. How much you need to go down? By H2, right? You coming the H2, what is the your manometric fluid over here? Okay, there is a one thing in, I need to mention. I think I'm making mistake over here, that we cannot walk down from this point to this point. We can walk down. Look carefully. Is there a same fluid?
No, sir.
Yes or no?
No, sir.
No, is not the same fluid, right? Because this side has a well. Top of point B has a, now this side has a water, right? And top of the point B has a well and bottom mercury. So there is no way you can swim from right here to right here. No way. So you have to look little carefully what I'm saying, that at first from here you walk down right over here, that means you are right over here. Now, even from here, you cannot come down right over here, right? So from here, if you come down right now, you can come down over here. You see, from here, you can come down over here. So if you come down right over here, then you see what do we have over here? Bottom of this point, we have
Waters.
water. And top, we have oil, right? So from here, if I think this point is belong to the oil, then I can jump from here to here. Okay. So my travel point will be from here to here, then coming here. Then from here, you walk down here, then you're coming right this point, right? Then come over here. Then you move to the point 2. So this will be accurate path. Otherwise, you will miss it. So this point, pressure P1, you walking down through the water. Again, you see, we cannot go from right over here to here, no, because this is oil, this is water, not in the same fluid. So P1 plus, you come on this mass, so H1 rho water G. So you're getting this one. Now, from here, you're coming right over here. Same pressure, over here and over here, same. Then coming to the point B, that means is height H2 is coming down. And density of the fluid, rho oil. So rho oil G H2. So you are not at point B. So from point B, now you coming right over here. Then you moving upward, then minus H3 rho mercury, H3G, height is H3. So rho mercury GH3 equal to atmospheric pressure, P2. P2 is atmospheric pressure, right? Then you figure out the P1. P1 equal to this one. Just simplify the equation. You take out G and you put all the value. Even over here, you put kilopascal, but you convert in Newton per meter square. Then it will be easier. Then you calculate. Over here, they put kilopascal, but if you convert it this one, Newton per meter square, then your result will come in Pascal, then you divide by 1000. If number is too big, then it will be kilopascal. Okay. This is one thing. And also you can figure out in alternate method. Okay. And in the slide, I was showing over here this P1, P2, PA, A and B actually right over here. Okay. So you might be confused with this one, but we can do other way. Okay. Say if you figure out the pressure right over here and right over here, then what will be your result? Say I'm saying this is my point A, this is my point B. So figure out the pressure at point A. So PA will be how much? Pressure A equal to pressure at point 1, P1. Then you need to go down. So plus height is H1. H1 rho water into G. So you are at point A. Now, how we can measure pressure at point B? So at point B equal to, you start from here, P atmospheric pressure at point 2. So P ATM. Then from point 2, you are coming down, H3. So it will be plus H3 rho mercury into G. So you are now right over here. Then you come over here, same pressure, right over here and over here. Then you moving upward by what is the height? By H2. This height is H2. And fluid is oil. So minus H2 rho oil into G. Same equation, but if If you think this point is right over here, then it's problem. Actually, this A is over here, B is over here. Okay. Then you say PA equal to PB, then figure out the pressure in the tank. Any question? Anyone? No question? Okay.
No, sir.
Our class, what time finish? Okay, we can solve this problem, then we'll take it off, okay? You see, this problem is very easy, just 2 minutes, okay? You see, this is the tank, M and N, and vertical height is H between the tank. And right over here, this height is Y, this height is Z. Over here, it has a mercury. And you see, both tank has a same kind of fluid, right? Now, how we can measure the pressure difference between the two tanks? So it's saying water filled vessel shown figure below. Specific gravity of the liquid right over here. Rho is not given. They're giving specific gravity. What does mean specific gravity? Anyone? Specific gravity equal to rho of the fluid divided by rho water. So this value 0.9. So easily you can get rho m equal to rho of density, right, of water 1000 into 0.9. That means 900 kg per meter cube. So they, instead of density, they give in specific gravity. Difference in pressure intensity. Fine. You need to find pressure intensity at point M and N. That means tank M and N when height H equal to 1.5 meter, Z equal to 0.3, and Y value is not given. This is one problem. Second problem, instead of water, if mercury in the vessel and manometric liquid has specific gravity 1.6, then what will be the pressure difference? If A is equal to 0.6, Z equal to 0.1. So ultimately, just two problems with different situation. Okay. So let's see, very easy. If you just write down the manometric equation, then you can solve it easily. So let's figure out that where you can draw the line. Okay. You see this problem, you can solve it different way. Number one thing, that you can draw a line right over here, both fluid in the same line, right? You can figure out you can say this is point A, this is point B. You can figure out the PA, PB. But I figure out right over here through the manometric fluid, right over here. Then you figure out pressure at point 1, pressure at point 2. So let's figure out point 1. Point 1 attached to the tank M. So if tank M has a pressure PM, so I can say P1 equal to PM. Then from this point, you moving upward, right? That means value will be negative. So minus rho water G, what is the height? Y plus Z. Height is Y plus Z. So this is P1. And similarly, P2, you'll start from tank 1, N. So what is the pressure at tank N? Pn. So I say P2 equal to Pn, then you first come right over here or directly come over here because same fluid. What is the height from here to here? H plus Y, right? H plus Y, then you can say rho GH. That means you will get these two value. Then you go that much. Height is Z, but your manometric fluid will be rho m. Then you say P1 equal to P2. then easily you can figure out the difference. Very simple. Before that, you will figure out the data that A is equal to this mass, Z equal to this mass, specific gravity of the manometric fluid is this mass, row of water is this mass, and figure out what is pressure difference between two tank, Pmn equal to what. Then you solve the problem. Now, the second one is the same thing. You just need to, this is the problem A, I figure out 12 kilonewton per meter square, okay? And the part B is the same, just send some data. In that case, values coming 38 kilopascal, okay? So any question? Any question?
No, sir.